Morning, everyone, and welcome to stream number 3, where we are going to start to build something a little bit more complex. So, in the Co-Engineers course, we've learned some of the basics of how to use Claude Code. We've looked through lots of cool things like how to build knowledge vaults, how to work with processing data, skills, MCP servers, that type of stuff. Now, what we done last week, we built a kind of really simple application around some forms. And this week, we're going to build something a little bit more complex, where we are going to be building something like a Monday.com competitor. So it's going to be a kind of project management tool, something that you would have saw if you've got a ClickUp or a Microsoft Planner account. So really what we're going to do is kind of build upon a base application that I've created. And what we're going to start to explore today is we're going to start to explore like some of the more nuanced and kind of trickier subjects when we start to think about building applications. And ultimately next week we're going to build something that's going to be fairly complex. And then at that kind of point there, we're going to finish season 1 of Co-Engineers before exploring season 2. So let's get straight. Hopefully that's better now. Jeval? My friend, can you hear me again? I just saw that we've just lost sound, so I'm just making sure that we're back on track. I think we are. Cool. I think we're back on track. So anyway, and then after, so the kind of key bits that we went through was this specify, plan, tasks, and implement lifecycle to ultimately build the components that we looked at. So then after that, we kind of built an application. And then the kind of core thing that we went through was the kind of 5 techniques. So the first one was around building this PRD that described the application. Then we built this constitution file, which was the kind of core rules for the system. Then we built the Claude.md file, which was for our technical requirements. Then we looked how to reset context, and then we looked how to kind of evolve our system. Now, one of the core things that I'd like kind to explore, and a lot of questions I get asked, is that these tools are really powerful, and increasingly, like non-skilled developers can build really interesting applications. Nevertheless, when you haven't kind of went through the trenches of working with databases, working with security, and kind of really understanding how applications are built, I would really kind of hesitate if you are from that type of background without doing at least a kind of month of going through some of the basics of ever working with some real data. So what you can do in that kind of scenario, if you are from a non-technical background and you're using some of these applications to kind of get comfortable, so everything we're going to be doing today will be local, Then what you can start to do is use communities. There's some amazing communities out there. One that we're going to be building soon, where you can ask some real developers to look over your code. And also, if you want to go and build an application and you want to get into production, there's loads of amazing things like on Upwork, Fiverr, where you can get a real dev to go and review your code for a few £100. So if you have got an amazing idea and you want to build something quite quickly, and you're from a non-technical background, although these tools build amazing testing frameworks and you can kind of get everything into production, I would always try and get someone to give a real validation if you come from that background. So for further ado, let's get into today. So really the kind of story so far. So we've kind of built our we built our growth forms, and now Hoddle wants a little bit more. So he's spending a fortune on Monday.com, and he's challenged the team and said, well, why can we not build something ourselves? So what I've done for you and what is available to accompany the stream is inside this GitHub TaskMaster, we've got a basic application. So basically what I've done is I've used Speckit and I've went through the cycle twice to build some core architecture. So the kind of core things that I've built is some databases, authentication that we're all going to kind of go through. I've also built the kind of the core structure of the application that we're going to be exploring today. So you can pull this and either come out, you can either follow along, or if you're not following along, you can pull this in your own time. And really, all you need to do is go into Claude Code and ask it to pull this application, and then in all the README steps, it'll help you kind of set everything up. So the core things that you'll have to have installed is, first of all, you'll need Node.js from last week. So Node.js is basically where we are going to be kind of running our Claude application in the runtime. The next thing we're going to need is something called Docker. So once again, this is a free install, and Docker is basically a containerized system that we can run applications and we can transport them to different places. It gives us some extra safety and security. So essentially, if we write an application, so let's say we write our growth forms and we wanted to share that application, it might not run consistently across Windows, Linux, Mac, whatever it was. So Docker gives us that consistency. What we're going to be using Docker for today is we're going to be using it to run our local database. So essentially, like, all you need to go is either install Docker desktop from here, or if you have got on Mac, or you can just use Brew, or if you are on Windows, then you can use PowerShell. So essentially, like, Docker is, and we're going to go through Docker and what it is in a little bit. Then the final thing that we're going to need is Supabase. So Supabase is the database that we're going to be using. We're going to be using it locally today, but Supabase has a really rich free tier. So essentially what you can use, so what Supabase is the core is a Postgres database, which is probably everyone on the stream has heard of a SQL database. It's one of the market leaders with Postgres. So Supabase is a wrapper around that and a whole bunch of other things. So it gives us things like functions, real-time monitoring. If you're an AI developer, it gives us access to a RAG database. So there's loads of things inside Supabase. So next week, we're going to actually hook to Supabase in the cloud. But for today, we're going to be using it locally in our Docker containers. So just to go through the application that I've built for you. So this is the co-engineers, the task application. So this application has got authentication. So when we kind of log into the system, essentially when we press sign in at the moment, what is happening? So because it's running locally, I've got a very kind of unsimple password. You probably can guess what it is. But basically, what this kind of happens when you log in, this goes to Supabase and authenticates with Supabase. So we're authenticating against the database with a real user to kind of log in, which is pretty cool. So the core features that I've built so far, first of all, we've built this dashboard. So the dashboard shows you how many kind of tasks that we've got. And then finally, what we've built is this task board. So what the task board has got and what the task board is kind of doing is essentially just managing our tasks. So we've got a way to kind of add new tasks. So let's say John task. And let's say the description is John doing a stream. And then the date for this is, let's say it's for today. And then create task. So when I create that task has actually been saved to the database. And really, we're going to use this as the base application today to build some more features. But the kind of core thing is we're going to go through Speck-driven development again and run it through 2 times. So this stream I don't think is going to be quite as long, maybe 60, 90 minutes. But also what we're going to do is kind of cover some of that key topics of some of the development tools that I just mentioned. So just before we get going, so I'm running Speckit in the background so we can just take everyone through it. Any questions on the stream just when I run old speckit.tasks? Did that make sense to everyone? Cool. So let's just kind of go through the key parts of what we're going to be doing today. So for the build today, the things that we're going to be building are 2 things. So into our application, we're going to build some different buckets. So essentially at the moment, I think we've only got, if we go back to the app, we've got to do, in progress, and done. So there's no way to add buckets. So that's going to be the first bit of functionality we're going to build with Speckit. And then the second bit we're going to do is we're going to add subtasks and checklists. So essentially you can use this application going forward as the base to go and build something way more complex. So you could go and build a task that goes and calls OpenAI to go and get more data, for example, or you could build a task board that can have multiple people signed to a task. We're going to use 2 examples today, but the kind of core thing is to really drive home spec-driven development and also go through some of the key features that we're going to be going through. So on the background, what we've got running at the moment off screen is I've got the first Speckit running. So one of the things I think it was not the best last week on the stream was just watching the actual code running all the time. So after it's run for the first spec, then we'll just kind of step through the code and the logic instead of just kind of reading all of or just waiting for it to complete. So the first tool that we're going to speak about today is going to be Docker. So if you've kind of come from a development background, you probably have used Docker a fair amount. And like a little bit of an analogy to think about Docker is a little bit like a lunchbox. So essentially you've got all your kind of code and your databases and you can put it into this safe lunchbox and then you can share it with different people, or you can think of it as a container. So if we're building an application, let's say the application is a Typeform competitor, and let's say that Typeform competitor has got a Node application and it's got a database, and we want to share that with other developers. And that other developer, one might be running a Linux machine, one might be running a Windows machine, one might be running a Mac. How can we consistently run that software across those different estates? So what we can put into a Docker container, that lunchbox, and then we can then share it. So I'm not going to go really in depth of what is Docker, what is the kind of commands, all that stuff you can really work through with the LLM and ask some of the key things. But what the kind of key point that we're going to be looking through today is that we have set up our Supabase instance inside Docker. So if I just quickly go to the Docker application that I've got running, so you can have a quick look. So after you kind of download Docker and you get up and running, you can then start to use these things called Docker containers. So basically at the moment, what I've got containers running for is this thing here. So if we just kind of go into here for my database, and we're going to go through the database and what it is in a little minute, essentially it's set up these different services for us in these little lunch boxes. So first of all, it is set up an API so we can speak to Supabase, so we can speak to the database. It's also built a nice user interface so I can interact with my database and a whole bunch of other things. So if I just open up, it gives us access to storage, real time, a whole bunch of cool things, and also authentication. So basically, like what we're going to be using Docker for, as I said, is running our application. But at the end of today, so say for example, we have built the absolutely most amazing Monday.com competitor, and we wanted to share that with the whole world. We could package that into our Docker container itself, into our lunchbox, and hand it to other people. So you build this thing called a Docker image, which describes the operating system on, blah, 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 all the instructions. But really, you put it into this package, into this container, into this lunchbox, and then basically that is the Docker image. And then when you run the actual image, then it comes a container, and then you can go and access it. So we are using Docker, as I said, at the moment for our database part of this program, but you can use it for the majority of other things that you're going to be using. So we're in a pretty good place. So what I'm going to go through now is we're going to go and run this first spec. So we're going to talk through the first spec, and then what I'm going to do is asides is when the specs are running, then I'm just going to talk through the different parts of the scenarios so that we're not just waiting for the LLM to always finish. So I'm just going to get up my warp panel, and I'll get this up, and I will just take you through where we're at. So if we just go a little bit up, so we can see that we've done quite a lot, and I'm just going to look at the kind of key parts. So let me see. Cool. Just looking where we started. So this is the type of thing that we went through last week. And great. So here was the first question that I went. So I went speckit.specify. So this is the kind of first thing that we're going to build. So we're going to build the reusable buckets, and we're going to alter the database, and we're going to cover the database when we get this running. And inside these buckets, we can add tasks. And if the task is not assigned to a bucket, it's going to go to a special bucket called uncategorized. And then that is basically the core feature. So first of all, I ran speckit.specify and just told it that user story. So basically then what it done, it created a new Git branch. So we're going to cover what Git branches are, but essentially it created a work stream to go and plan this feature. So what it done was it went through all of that stuff there for the spec, and ultimately what we got in our specs folder, and if we just go and look, is we got the initial spec. So if I just open that initial spec, and we'll just go through it super quick. Oh, yep. So the kind of first one is to create and manage the buckets. Makes sense. The second one's about collapsing and expanding the buckets for the UI. There's a one for reordering the buckets. There's one to move tasks between buckets, and then a few different edge cases. So that was what happened when we ran speckit.specify. Let me just close this one. So then what it continued to do, so after that we further down, we ran speckit.plan. So after the kind of spec was all written and stuff like that, we then ran speckit.plan. But interestingly, before we ran speckit.plan, the AI came and asked me about a couple of bits of functionality and how I wanted to do it. So it asked me about how when a bucket's deleted, what happens. It asked me about when we collapse and we reset, what should happen. And when we reach a maximum number of buckets, if we want that, what should happen? So I said, for example, I wanted a limited bucket of 20. So in that now, after that, I ran speckit.plan. And then what that plan done here, so if you can look here, I ran speckit.plan. And essentially what that plan then went and done was read all of the different technical documents that we need. So for example, what it done was it done the data model. So this data model here is the stuff that is actually going to add to the database. Why is this not closing automatically? I'll work this one out off screen in 2 secs. But anyway, so what we've got is we've got the data model, we've got the buckets, and we've got that type of stuff there, which is all very, very cool. And then finally, last but not least, we want to speckit.tasks. So speckit.tasks essentially has went and run everything that we are going to be doing. So this is like the kind of the tasks over here to the left hand side. So this is what the AI is going to go through. So first of all, it's going to make some changes to our database. Then it's going to add the bucket functionality. Then it's going to actually do the different parts of the buckets and that type of stuff there. So we're at a place now where we're actually going to go and run that task and implementation. And while that's doing it, we'll start to speak about some other kind of key concepts. So I'm just going to go right down to the bottom. And if you remember, so if we remember from last week, so we're using our context window. So if I run dash context at the moment and see how much of the context window we've used up so far. And we're on, how much of the context have we used? We've used about 95,000 tokens. So we're about halfway through the context, so I think we'll start again. So we're going to go speckit.implement, and then we're going to pass in our tasks. Oh, that didn't quite get it right. Speckit.implement, and then passing in our tasks. So while that's working on the background and it's building our next part of the feature, we'll talk about some other parts. I'm just going to try and work out why the panels weren't closing on my thing. Works absolutely fine when it's off screen, so there you go. So any questions, anyone on that? So the kind of core components that we've done so far, we've just talked really briefly about Docker. As I said, I don't want to go through every single kind of technical detail, but what we're using Docker for is like this pack lunch box to hold our database. And then we've went through the speckit.implement, and what that now is going to go and be building the bucket features in from the product backlog. Cool. Any questions? No questions? So let's keep on chaving through it then. So the next thing we're going to look at and talk about is GitHub and Git version control system. So essentially what the Git version control system, you can kind of think about it like Microsoft SharePoint, which is all there about accountability for your documents, having that backup mechanism for your documents, but it's primarily for code. So what you have got access to via this application is the code that I have built on Git, and then I've stored it on the cloud in github.com. So basically you've got access to this, and essentially what GitHub is something called a distributed version control system. And what that means is essentially we can have code on our application, on our system, on our laptop, and we can also have a copy on the cloud. So kind of like in SharePoint, when you've got a document in the cloud and you've also got it in your desktop, Git gives us a mechanism to kind of have these different versions of the different codes in different places. So if we've got a development team, for example, if it's me and Shafiq and Ed, 3 people that are on the stream today, if I can have it on my computer and Ed can have it on his computer, Shafiq can have it on his computer, but also we would have a copy in typically a cloud environment. So very similar to SharePoint, and it's like a way for us to kind of share code in a really kind of well-managed way so that we can share and work on things together in a team. Gosh, it's getting through this features today super quick, so it's already nearly finished the first spec, which is quite cool. So when you're working with Git, so what Claude Code is going to do is going to extract quite a lot of this away from you. So like what you're increasingly not needing to know is every single command that's going to be in Git. We'll talk about some of the key ones just so you kind of know what's happening. So when you want to get information, or where you get from Git the repository that you want to have to access, you kind of clone the repository. So the way that you would do that is that you would have this URL, and you could say to Claude Code, or you could say from the GitHub or the Git application, git clone, and say where the application is. After that, you've got the application. So when you run this command, literally you would have a code base similar to what you just saw before when I was kind of taking you through. So this code base here, you would have access to it. So at that point there, you can then start to work with the code base. You can add new files, you can delete files, and basically you can add and delete and do all that things both locally and into the cloud. So for the kind of the people on the call that went to go through the commands, first of all, you'd add it to your local repository, then you would commit it to your local repository, and then you would push it to the remote. But with Claude Code, what you can just say is, can you kind of store this to GitHub and then it's going to go and do it for you, which is particularly cool. So in this GitHub, the other thing that it's really good for is having independent work streams so we can build different features together. So let's say, for example, we're in our taskboard application, and let's say that I want the application to stay up and be really high quality, but I also want Ed to build the features for buckets. I want Shafiq to go and build the features for checklists, and I'm building the features, say, for the OpenAI integration. So how can we do that in a kind of high quality way without breaking the existing application? So what we can do is we can use something in Git called branches. And essentially what a branch is somewhere where we can go and build a feature. And then when that feature is complete, so for example, Ed finishes his feature, then he can go through a process to get that feature into the main branch. So essentially we can go through like a quality review process, and we can use this feature branch model to make sure our code doesn't get broken and it's got tests and it's high quality. So what is happening when you have been using Speckit in the background? Every time you create a new feature, so when you say to a user story, A, B, C, I want to build the kind of whatever you want to build, it builds a new branch for you. So like under the hood, it calls get branch, it creates a branch, and then you've got this kind of stream of thought to go and build different things on. So why this is really useful is that you can start to like work with Git in different ways to kind of save your code. And like what I would suggest what you do, particularly if you're new, is to be saving to Git all the time. So one of the things that you will get to with AI is that you'll get to somewhere where you're in quite a good place and you'll be like, oh yeah, my application's working really well. And then something will go wrong. And then you'll just be like firefighting thinking, how do I get back to the state where it was working? So if you used Git and you had kind of saved your information to the version control system, then you can just roll back. So you can go back to the state where it was working. So the more times that you save to Git and you kind of save on Claude, go and save to Git, then the more robust that your application will be if something goes wrong. So really the kind of key parts from Git, just to kind of think away a bit, you can think about it as SharePoint. So it's a way for us to kind of share and control versions of code. It gives us the ability to do it both locally and remotely. And then most importantly, it gives us a way to build independent features so we don't break the main program. And while I'm just coming to the end, we're nearly at the end of this feature. So we'll get to see what happened when we ran through the last speckit.specify. So here it just speaks about some of the key commands that I mentioned before. So git add, like saves the file to your local repository as an uncommitted change. Git commit adds it to the database, and then git push pushes it to the remote. And then the branching thing that I spoke about before, how do you build a new branch? You use this checkout mechanism. But as I said, in the whole, what the Claude is going to do for you is abstract quite a lot of that away. So when you're kind of going through it, you can kind of speak to Claude in natural language instead of going through every single one of those different commands. So if we just get up and we kind of go back to our application and see where we're at with the build, we're starting to get into quite a good place. So what it's done is migrated my database to add the new changes. It's built the foundational components, and now what it's doing very comprehensive testing. So the actual features are finished. So if you remember last week, we said we weren't going to do testing, or I didn't do testing on the stream just because it takes a significant amount of time. But because I want to start to build things that are a lot more secure and a lot more robust, what I've got the application is doing is building unit tests and integration tests. We could do well, I was going to do end-to-end tests as well, but launching the browser, which have loads of pop-ups, and it would have been really, really weird for the stream. So essentially, like, if we just kind of talk through and go through all of the things that it's went through on this kind of build. So what it's went through is, first of all, it's built all of the front-end components. Then it's built these things called hooks, which do the data manipulation. Then after that, what it's done is built the database scripts further down. Then it's run those database scripts. Yeah, so it's run the database scripts there. And then what it's doing now is doing all of the different tests. So you can kind of see here with the tests, what it's doing. It's creating my buckets, and then it's testing it all works. So, so Javal's just asked a question. So, are the features from the last session still present in the project? No, this is a completely new project, Javal. So this one is entirely different. So the GitHub for the last projects are both up on my one. This is a completely new one. So there's going to be, at the end of next week, 3 projects that are there. There's the first project, which is the form application that you'll have access to. This one, which is the task planning board that you have access to. And then the next one is next week one is going to be a really cool one, is going to be the CRM application. So I think that's about finished now. So it's just, you can see at the moment it's running tests, and some of the tests are still failing. So there's one failing test. The text now appears twice in the column header. So essentially, these tests are proving that my application is quality. And if we now go back to our app, we can see now we've got this new add bucket feature. So let's give it a test bucket. Failed to create bucket. Interesting. So if we just get our developer tools up, and we can see here, something's happened with the database, and it looks like the way that it's saved the bucket into the bucket has not got the right object. So what we can do is just take this information, and then we can copy it, and we can go back to our coding assistant, and then we can kind of put that one in. So bucket not saving. So that's just one of the things, and that's why if we went back to that kind of methodology around Git, if we kind of saved it at that Git point there and it's not working, we can kind of go back to it. So something in the moment inside the code is failing to load the resource, conflict in buckets. Oh, actually, I know what that was. I think that was my fault. So let's say, oh no, I've not got a test bucket. So let's see what our problem is. So at the moment, what the AI is looking through is why that is failing. So if we just get that back up, we can see that this object here is not being stored into the database. So it says that there's some kind of conflict. So when it ran this statement here, it failed. Cool. And this is like one of the kind of workflows that you'll get used to kind of going through, is you'll find an error, or the AI will find an error, and then you'll just need to work through it. So if we just go back to the AI and see where we're at. So it's checked the auth provider, and it said that it's got a problem here. So essentially, like when it's putting this name in, it's not putting it in a validated form by the looks of it. So it looks like it had to trim this name, and then it's also added some extra validation if it's broken again. So the profile error on line 95 is a development. The 49 creation is a unique constraint violation. If you're testing, run the database. Cool. So I think we need to rerun our database to make sure the changes worked. So I'll just go into here and we'll start that, and we'll rerun our database. It's recreating our database for us, and then hopefully after that's recreated, and we're going to go through the databases when we're running through the next spec, hopefully we'll be in a really good place. So it's creating all our new tables for us. It's adding the data to our database. Where it's saying this restarting containers, that's where it's restarting the Docker thing that we spoke about before. And now hopefully we'll be in a little bit of a better place. So if we go back to our application again, and this time it's probably logged us out, and then we go to add bucket, and this time we add the test bucket, and the bucket still failed to create. So let's have a look again, and we're still getting this 406, So this is really good when we're getting this. So let's just go back and just make sure we're getting some clean debug that we're given to it. So I'm going to go back to the bucket. I'm going to go to test. So this is the command that's failing. So I'm going to copy that. And what you can do with the AI as well, you can ask it to make a plan to solve this particular problem. So I done this, and I'm still getting, and can you make a plan to fix it? So basically, it is still getting this kind of conflict error, and it's to do with this uncategorized bucket by the looks of things. And what we're going to do now is something slightly different. So instead of asking the AI just to go in there and fix it straight away, we've asked it to go and make a plan. So if we press Shift and Tab in Claude Code, then that will give you these different modes. So when you're in the plan mode, what it's going to do is it's going to go back, it's going to read some of your core files, and then what it's going to then come as a plan to go and fix it. So you can read through the plan and make sure that it's a good plan and it's not going down a bit of a rabbit hole. So what at the moment it is kind of going through the workflow, then it's looking through the different files, and any second now it should come up with a plan that we can that it can go and fix for us. So what's really interesting, and all the time that I've been building these applications and fairly complex ones, is not I've never had to three-shot it, and by three-shots I mean have to give 3 calls. So quite cool that it's happening on the stream, and we're working through something together to kind of work out what the problem really is. Cool. So what the AI is doing then is, as I said, we are just working through the plan, and we'll just give it a little minute more. And if it's going to be more than a little minute, what we'll do is we'll start to speak through the other bits of the workshop. So I think it's going to be a little minute. So let's just move this over and continue to talk through the workshop when it's doing that in the background. Cool. So in the background, what it's actually doing, which is fairly cool, it's using the MCP server. So essentially that's something we're going to cover next week. But there is a special type of way to connect to external services like Supabase. And essentially what it's doing, it's going using that tool to go and work out what the problem is. So it's asking me what the error is when I add a new bucket. It just says failed to create bucket. The toast says failed to create bucket. So I'm just doing this on the right hand side, and then I'll copy in this extra debug that it's put in to help it work out what the problem is. We will keep working through this one. Cool. So these are like some of the kind of major learning points that you get here. So when you're working through these tools, sometimes it takes a couple of things, especially when there's a little bit more complex requirements, to work out why things are not working. So if we just go back and have a little bit of a summary where we're at. So what we've kind of looked through so far, we've looked at the basics of Docker, and we used Docker to store our database, which is now the kind of key thing that we're going to talk about. We also have spoke about the basics of GitHub and the Git version control system, and we're using that for this feature development. So this is a really good example here. If I was just working with my kind of core main branch where I've got my kind of code, and then I kind of done this, I built this feature and I launched it, then all my users are going to get a broken feature. So because this is on a feature branch, it isn't going to break the code. So on the background now, it looks like it is worked out what the issue is. And it looks like it is because there's a forward key violation because there's an unrefreshed token. So let's see if it's going down the right thing. So it's basically saying that the feature works, but because we are not in an incognito window, that's the reason. I'm not sure this is right, but let's have a look before it does it. Is it 3000 we're on? Cool. If we just log in, and it's password 123. All right, let's go back to our app. Okay, so it's just coming up with after debit, blah, blah, blah. So we're just running that in the background. So it's saying it's a session problem, but I don't think it is. So it's just running it, it's fixing the auth provider in the background. It's going through the type check and the tests. If we just go into our database, we're going to create a new user at test.com. We're just going to cover what this is in 2 secs. At the moment, I think the database is just getting reset. We're just going to add a new user. Password. So it's saying our database isn't running. Just have a quick look. Yeah. When adding a user. I'm just working out why this isn't working in the background. And I think we're nearly there. So in the background, just getting the database reset up. So what it's just going through in the background is just resetting up our users. So it's a really good example of something where it's went fairly wrong, which is quite cool on the stream. So what it's just going through now, it's just going through the migration to recreate the tables for our database that we're just going to talk through in a little minute. And then hopefully we will be good to go any second just after it's run it. So it's running through the SQL statements that we're just going to speak through. And it's reconfiguring the database. And it's still failing, which is cool. So just working through the database connection now. I think we're just about there. What I'm going to do is I think we'll just take 5 minutes. I'm just going to go through that, so we're just not going through all the different streams. I'm just going to do a little bit of fault finding. So we just take 5 minutes for a break. I'll work this one out, and then we'll be back on just in a couple of minutes. So welcome back, everyone. So just one, on the background there, I was just working through the debug issues. So essentially, what was happening was there was a conflict on the database initially, and then actually when it got the feature implemented, it didn't implement it right. So it's really good learning point. So what I think has happened is when I've went through the kind of tasks and that I've not read through them thoroughly, which is a really good learning point for everyone here. What it's done inside the tasks, it has created this new bucket functionality instead of adding it into the status column. So it's kind of get it back now. We could go and run through the whole feature list to go and build that one again. What I'll do is when I do the full publish, which will be probably later on today, I'll rework that one now. So it's kind of working now, and by my kinda, it's not really working as a new status. So we could go and run through the Speckit thing to go and fix this functionality. But what I think we'll do is we'll kind of crack on with the next one. So what it's done, it has added these new buckets. I can't do that one because that's already one called test. So we'll call test one. So now we've got this test one bucket, but it's not got done the same as to do in progress and done. So it's done a completely new entry in the database and a new column, and we'll go through that what that is now. But it's a really good example of when you don't get that spec quite right, then the functionality is going to be wrong. So just going to add a task. So let's call our test task, and then say add data to the DB, and then create a task. And now that task's in there. So it is starting to work, but the only thing is it's a little bit different. What we have done is that it's kind of got this different things between what a bucket is and what a status is. So that's going to be a bit of functionality I'll fix when we are off the record. So what we're going to do now is we're going to run through the final specify. So we're going to go and do the subtask and the checklist, and we'll go through that in detail. And then whilst that's doing, we'll talk about the final bit of the stream around the actual database itself, and then we'll be cooking on gas. So I'm just going to go back and we're going to get up our specify. So off stream, this is just what I was kind of doing. So if we just kind of look through some of the debug that I was doing, and so we can see it. So essentially, what it was kind of doing, it built this bucket column. And I said, well, the status column doesn't have the bucket in it. So the status column is where it's got the to do and the complete and the in progress. So then what it done was created this new button for me. And then we could go and just run another one to go and redo the database, as I said before. But I think for the interest of time, what we'll do is we'll just run through the next specify. We'll make sure that the requirements are super clear this time. And then we'll talk through databases. So I'm just going to clear it, start a new context window. And this time we're going to run speckit.specify. And this time we're going to get the user story for subtasks and checklists. So if we just go to coengineers.ai, and if we just go and look at the stream details from today, and we go down here, then our user story, I think, is just towards the end, if I remember right. Yeah, so here's user story number 2. So as a user, I want to break tasks into subtasks and checkboxes so I can track granular progress and see completion percentages on parent tasks. So we're going to need a new database called Subtasks, and it's going to need these things here, a percentage of the task completed. That all looks really cool. So we're going to go back, and we're going to go back to our trusty editor, and we're going to run speckit.specify, and we're going to pass this one in. And let me make sure we've got everything that we need. So it's got checkboxes. Yep. It's going to build the database tables. Yep. That looks good to me. So that's enough for that one. And as I said, like what I have done before the stream today is created the PRD, and it's got all the user stories. And what I've done is just updated them to the website that we're going through. So that's going to work away in the background. And whilst it is doing that, the final bit we're going to talk about today is around Supabase and the database. 5, 4, 3, 2, 3. Cool. So if we just kind of go back up into the bits that we've covered, so we have spoke about Git, and we should have done a commit before that, which is my bad, but we'll just run the next feature through, then do a commit. So the final thing that we're going to speak about is Supabase. So if we just go back to last week's session, we were storing all our data locally to the web browser. So basically, in the web browser, there's something called local storage, which is this small database where it can store information on our forms. What we are going to do now is that we're going to use a real database. So we're not going to go through databases in significant detail. If you want a session on databases, my friend Shafiq, who's in the stream, will do the most in-depth database session that you've probably ever come across. But I just want us to get a working knowledge of how this database works and some of the key things in it, because when you download the application and start to work with it, we have got this database running in Docker. So a really good way to think about a database is kind of like a spreadsheet. It's kind of like a spreadsheet, but the kind of thing that's really important about the database is that it's got a number of properties that we can have for data integrity and making sure that our data is secure. So on the left-hand side, we've got our spreadsheet here, and on the right-hand side, we've got our database table. So you can see that they look kind of similar. So in a spreadsheet, when you're working it, you kind of got a table, and in the kind of spreadsheet form, it would be a sheet. So like if you're kind of thinking about this analogy, they're kind of similar. When you've got the columns on a spreadsheet, so say for example, we're having a spreadsheet of people, and then we've got columns of name, last name, email address, that type of stuff, that would be the same in column headers. In a spreadsheet, you've got your different rows. So let's say it's a person. We've got John 123. His password's 123. Example. Then we've got this. What we call in the database would be a record. And then the main difference is what we can do in databases is we can link different tables and records together. So the way we do that is using something called a foreign key. So in the kind of the Excel form, it's like a VLOOKUP when you're linking data together. So for example, at the moment, we have got a user, and a user can be linked to many tasks. So basically, we've got a user table, we've got a task table, and we can link them together just like you can in a VLOOKUP, and that's what brings you together. So the current structure of our database that's kind of been built for you, we've got a user table. So the user table that we have got has got an ID, it's got an email address, it's got the name of the person, and it's got a timestamp. And then also what we've got is we have got a task table. So we've got the ID of the task, the title of the task, the description of the task, the status of the task that we messed up last time, the position where that it's sitting in the actual the hierarchy, and then really important here is who that task is related to. So that's the thing that kind of brings them together. So as I said before, the application that we're using is called Supabase. And if we just go into it, so Supabase at the moment is running inside Docker, so in our lunchbox of different things. And on the left-hand side, this is all the different services that we've got. So this week we're using Supabase that is running locally on our machine. Next week we're going to use Supabase inside the cloud. So Supabase has got a really free, generous free tier that we can kind of work with. So all these different things on the left-hand side. So when I was going through before, through authentication, this is how I added new users to my system. So I've kind of took that one out at the moment, so we can't see it on the actual stream. Then we've got, nope, I'm in a different database. So I've got a couple of different databases running at the moment. So this one that we're wanting to go on is on 243. Let's just have a look where it's actually running. It is running on localhost. This one here. And then it's on that port there. Cool. So in this authentication one, sorry, we have got one user. So this is the way when we're logging into our application, it's checking on this table for users that can access the system. And you can see here that, so for this user, it's got this unique ID. So this is the ID related to the user. And then it's got the mechanism that we signed up the user via email to prove it was them. And then on top of that, the other things that we've got in here is the tables that we're going to be working with. and a whole bunch of other things. So the only two things that we're going to be looking at very briefly is authentication. So that's the kind of mechanism we're using on our application to get into the database. And then on the second one is around our tables. So at the moment, the tables that we've got, and the tables that we've got is our profiles. So this profile links our user ID that's logged in to this table, and then we've got our tasks, which the tasks then are related to that user. So you kind of think about after we log in through that authentication mechanism, we add the user to this profiles table, and then as we add tasks, that gets linked to that profile. So the big mistake that we made before was instead of doing more updates to this table, it created this whole new a completely new a completely new table with this information. So that's kind of where we went wrong last time. So what we're going to be doing now is we're going to be updating the database with the checklist and all the information, and that's what's happening in the back end at the moment. So let's have a look where we're at with it. So if we go back to Warp, and let's have a look now and actually go through the spec in a bit more detail. So user story 1, add subtask to a task. So we went through this a bit too quickly. So as a user opens a task, they see a dialog, adds one more task to break into smaller steps. Each subtask has a title and can be checked off when it's complete. And then given a task, that looks good to me. And then we've got a complete button and the view button for it. So as a user checks off subtasks as they complete, the parent displays a progress indicator. Yep, that was one of the features that we wanted. We've got a mechanism to delete subtasks. Yep, that looks good. And we've got one to reorder subtasks. So that looks good. So what we could do now to make it simpler, what you can do is you can run this command speckit.clarify if you want to change the user stories. So let's not do user story 4 at the moment. So let's go speckit.clarify. And then let's say on the clarify command, we don't want user story 4. We don't want user story 4. So basically, like what that's going to go do now is going to clarify that requirements. So essentially what it's going to go and say is we don't need user story 4 in that spec now, and it's going to go and update it for us. So hopefully now you can see it's removing user story 4 and the associated requirements. So this just means it'll run a little bit faster as we're going through it. So we're looking through that one now, and it's working it through. New subtasks added, new row number started. It's got this cascade delete function. That's looking sweet. Cool. So now it's come up now with a number of questions. This is cool. The spec currently says the progress into Airshell is completely totaled. However, for task, cards on the board displays both tasks visually. So it's asking me how it wants to display the progress bar. Let's go with a fractional label. So let's go B for that one. So this is really cool. So when you run speckit.clarify as well, it gives the AI some time to ask you some questions. And it's quite good going through that just to really kind of double down on the requirements and get the requirements right. So it's now added that to the spec. So it said add 5 questions. Let's see what the next one is. Now add into the clarification section. So it's added into the spec. So it's saying that now when it kind of sees it, we're going to see like 3 out of 5 when we're kind of working through it. So that'll be the kind of the mechanism. We could display it with something like a nice little widget or something like that, but let's just keep it easy for this. When a user deletes a subtask, should there be a confirmation step or should it delete immediately? Let's say delete immediately. And it's really cool here that you're kind of working through with the AI to get to the stage where you need to be at. So we've worked through that next requirement. So the next one, how should completed tasks be displayed in the list? This affects scannability when a task has many subtasks. So what the things that's offered me, stay in place with striking through text. Yep, that sounds good to me. I think that's how Monday.com does it, if I remember right. I know for a fact that's how Trello does it. And then the next one. And you can see as we go through this process, what is updating on the right-hand side is our actual specs, which is unbelievably cool. Now let's clean up our entities. So now it's kind of taken away the database stuff that it needed for the display order, because as you remember, we said we didn't need that particular feature. The original description mentioned an extendable list in the task details dialog. Should the subtask section be collapsible or always visible when subtasks exist? Let's go for always visible. That's kind of how it looks, I think, on the Microsoft products. And then last but not least, what is the question going to be? That is a big question. The remaining taxonomy categories are all sufficiently clear. No critical ambiguities remain. So good. So then now we run speckit.plan. So we've reviewed that spec and we're happy with it. So now what we're going to do is go and let it work on the back end. So while it's just doing that, let's just kind of just go back through the key parts of the database and the things that we've been kind of going through. So as I said before, if you think about a database very much like a spreadsheet, and then the analogy of the kind of sheet, if you think about Excel or Google Sheets, the sheet being the kind of primary thing that you would talk about in a database, that's called a table. And the work and they're structured very similar. So the kind of column header that you'd have inside your spreadsheet is similar to a database header. And then for a row, we would call that a record within the database. And the core part of the kind of the database and where it's fairly different from a spreadsheet is how they work together. And they've got this relationship called a foreign key, where it kind of links one record to a number or one or a number of other records. Then we talked really briefly around the schema. So when you go through this code base today and you literally kind of start up the application, it's going to do all this in the back end for you, but it's just really good to know actually what's happening. So finally, the kind of bits that we're going to talk about is just how we've structured the code. And as I said, like for the people for you that are not from a technical background, starting to be intuitive and going through this is going to be really where it's going to help you over time. So you're not just coding things that you don't understand, but you're starting to learn how the application's structured. So essentially what I've done here is I've broken down the kind of key ways that the application has been broken. So I've built it using an architecture called vertical slice architecture. So basically that means that every kind of feature that we build is completely compartmentalized. And why that's really good is when the AI then goes to go and look to make a change to that code, it needs to go and look in one place. So instead of the code being kind of horizontally kind of thing where everything's kind of intertwined, when we do it this way, what it does is means all our codes for each feature are in one place. So some of the kind of key bits of the code that you will look through and can see. So first of all, you're going to see things like package.json, that type of stuff. And like that here. You're going to see things like supabase.config. You're going to see things like this source folder. And we're going to go through this in a little minute in an IDE so you can see what it looks like. But really like what this part here is, this package.json and these three other files are config for your application. So package.json tells you the application dependencies, so the other parts of things that you're using. So for example, Supabase. Then this file folder here, Supabase, actually shows you where all your database stuff is. So all the stuff that we had for our database is kind of set up here. And then in this source, this is where all the application code is. So we've kind of got some key parts here. So in the components part is all the different bits that you see for the layout. So in the application itself, and when we log in, when we look at this kind of taskboard and the shell of the application, that is all what is stored in this kind of layout part here. In the AI part or the UI part, that's where we've got all our different buttons and stuff like that. So if we come back here and all these different buttons and stuff like that, that is getting added in this UI folder. Then we have got some other bits and bobs, but the key part that we can see here is that we've got this features folder. So when we've got these features folder, we've got everything in one place for that particular feature. So we've got the components, which are the UI elements. We've got the hooks, which kind of do the business logic. And then we've got the mechanism to go through and call the database. So that's the way that it's kind of structured. So when the AI goes to create a new feature, it creates a new folder structure with them different components, and that's the way that it works. So just while we've been working through this, it's went through and finished the last parts. So let's just go and chat this one through. Cool. So let's go through the plan and that, and we'll go through it in a little bit more detail this time to make sure that it actually is going to do what we expect it to do. So it's got a summary, so it's going to be doing the subtask feature. It's got the technical context. It's got the constitution checks we're working on. It's got the plan for it, so it's going to do it in the taskboard feature. That makes sense. And it's got the database migrations. So that looks good. So let's see what research it done. So the research that it went and done was how to use Supabase RLS, which is a security mechanism. It's went and looked how it's going to do the logic for progression. It's went to go and see how it's going to go and get some data. That all looks really good. Then we're going to go through the data model. So this is the changes it's going to make to the database. So that's it, the database as it currently is. These are the policies it's going to set up. It's going to add this new subtask. That is going to use. It's going to build these validation logic. Yeah, that looks good to me. And then the API that is going to write. Yeah, so that looks good. So now what we're going to run is speckit.tasks, and that's going to go and work in the background. So just when we were kind of going through that here, so this is all of what I just showed on the website here is very similar to what we can see here. So on the left hand side, what we've got here is mainly just the configuration files. So the main one that we spoke about was package.json. So in here, it's got all of the different libraries that we're going to be using. So for example, the React library that we're writing with, Tailwind that we're using for CSS, all of the different things are in this package.json. Also some scripts that we run in to kind of start and stop our database. Essentially what these kind of ones outside the folders are all configuration mainly. Now one that's really important is this one, and for the non-technical people on it, this is a really important point. So when you start to work with external services, what you need is the details how to go and access them. So when you're not working with a normal application, you use a login, you use your username and password. But when you are working with an external service, typically you're going to have an API key. These API keys are extremely sensitive and are secret. The reason why I'm not bothered about you guys seeing this one because they're local at the moment, but when we start to work next week with external services, you should treat these as username and password. So if you go and hook to the Supabase in the cloud and you put your credentials in here that does that, and you expose them, say for example in GitHub, then someone would have access to that service. So if you're working with 11 Labs or you're working with Gamma or any of these different APIs and you're kind of connecting to them, it's really important that you kind of consider what this actually means. So like these ones here, so that .env one is where you would store that credentials for your real server. So for example, let's say we've built our application has something called OpenAI. We've stored our OpenAI information in here. What's absolutely critical is that you wouldn't add that to GitHub and source control. So as I said, like as we get used to this, and this is why we're running everything locally at the moment and just building things on one stage at a time. And the way that you can stop things getting put into your GitHub is that there's a special configuration file called gitignore. So anything we put into this folder and this file, it basically says the things that we will not push to source control. So essentially anything here, this things won't go to source control. So what's happened now, we've got our task list in the background. That's looking pretty sweet. Let's talk through this and see what tasks we've got then. So first of all, it's going to set up our table. It's going to add our policies. It's going to run them. Then it's going to do the subtasks. Then user story number 1, it's going to do the tests. It's going to use subtasks. Yep. It's going to do the complete view. It's going to do the delete subtasks. Cool. That looked pretty good to me. So I'm going to use Speckit.implement. In fact, we're going to start a new context window here. So Speckit.implement, and then we're going to say that. Cool. So that is going to go and work on the back end when we're going. So let's just go through a little bit more of these folders when it's doing that. So in the specs folder, that is going to be where it has all the different specs that you are working through. Some other really important files to kind of speak about. So in GitHub, when we were speaking about storing things locally, everything's stored inside this .git folder. Tests are self-explanatory, and we'll speak about tests in a little minute. This Supabase one here has all our information for our database. So this c.sql, this has got all the information that kind of runs to go in and run against to add stuff to our database. And these migrations here go and do all the different database setup. So if we kind of come across here, the create table, the create tasks, the create buckets, the add buckets, all that migrations are happening there. So essentially when we start our application, those scripts are run, then the data is added to the database, and that's what's happening in the back end. And then last but not least, we've got our source folder. So our source folder is where all our application code, this is the stuff that AI is building for us. So in our app folder, we've kind of got the high level object of our app and a router. So the router is when we go to different places where it knows what to go and add in. We have got our features, which we'll kind of speak about in a little minute. We've got the kind of core components. So we've got our layout that we spoke about before. We've got in here as well our shared components and our UI, all our buttons and stuff like that. We've got any external libraries that we're using. We've got our overall page structures here, so things like files not found, sign up pages, that's where all that stuff is. We've got providers, which are essentially working with external services. And then the key one that we spoke about is when you're using this vertical slice development is our features. So like we've kind of got that core things that we said before. We've got the components, we've got the hooks, and the stuff that works for database. So for the authentication feature, all that stuff's in there. And for the task board feature, all that stuff is in there. So let's say, for example, we created a new feature, and let's say that feature was an analytics feature. So we wanted a reporting dashboard for our tasks. It would have a new feature called reports. Inside that, it would have a component, a hook, and the database logic. So what's really good, so when the AI has to go and change stuff, it doesn't have to change stuff in lots of different places. It can just go and work with that one feature in that one place. So it says blocked. That's interesting. So it's really cool. So what it's doing here is writing TDD for us. So it's essentially writing all our tests first. So here it's kind of mocking out our tests and stuff like that. So what it's kind of done, it said it's not going to run into the user stories till those tests are all run and set up. I think that's a really good segue just to talk a little bit more about testing. So if we go back to our application, so here it's got the kind of core parts of the different files. So the configuration files and some of the ones that are most important, the database setup files, and then breaking down the source code again. So the app has kind of got the main entry point and the routing logic, as I kind of spoke about. The kind of key components like layout are in this components folder. The features, this is where our vertical slice architecture is. So each one is going to have the components, the hooks, and the database stuff. Our kind of key pages that we're going to be using. Different contexts that we're passing in. External libraries, for example, connecting to the database. And then going on to the kind of some of the other kind of key parts is the components is a bit that you see in the UI. So like all the bits that we're kind of, we go in here, is kind of working through us at the moment, so that's why that one's broken. But like for that component there, that would be in the components. In the hook is like when you're kind of changing it. So when you're adding that 3 to 5, or that kind of three to 5 quarters that are going to be in that progress bar, that's where that manipulation's done. And then the kind of service in the database stuff is the stuff it's going to call the kind of key parts of the database. So going through things unbelievably quickly. If you kind of went on, this was something you would kind of do a whole computer science degree on. So really, like, what I would suggest that you do is get into the LLM and ask some questions. So like, let's have an example of that. So let's say, for example, you're just absolutely dumbfounded on what the different folders are. So like, I'm just going to launch Claude from a different window. And then let's say that, yeah. Can you tell me about the folder architecture? I'm entirely new to software engineering. I've never done software engineering. Can you just tell me what happens in each folder, and so I can understand it, and then when you're building stuff, that I actually know what you're doing and the kind of key things that you're typically going to change. Can you tell me like I'm kind of a teenager, and give me the most amount of detail that you can? So basically what I'm doing here is that I'm working with the code base, and I'm just going to ask it some questions. So it's reading the code base, so it's going through the work in the structured folder, and then it's going to start to give me some information back. So it's asking me if it can read the folders. So let's say yeah. And in a little minute, then it's going to come back to it. So if you go into a new code base, for example, this can be a really good way to kind of get yourself up to speed. So it's reading at the moment, so it's got 22 tools running concurrently, looking over the code base. And whilst it kind of does that, I'm going to grab a little drink. Cool. So it's done that now, and then it's used 12 tools and 41,000 tokens to explore our code base. So what I mean by a tool, it was probably kind of used a tool like go and read my code, and it's used that 12 times. So probably one tool has looked over package.json, one's looked over .md, etc. So one of my friends just said, "Is that vodka?" on our private Telegram chat about the thing. No, Ed, it's not me. It's too early for that, particularly after what happened last weekend. We'll share that on a different stream. So it's still working through the tokens at the moment, but this is like one of the kind of key things that you can do. So if you're confused of how the database connection's working, what's in these special files. So let's see what it's done now. It's probably done a lot better job than I've just done spoken through the files. Let's go through this in a little bit of detail. Gosh, it has done the big picture. Your project's a task management app. Like a Kanban board, think of Trello or Notion. It has users who can log in, create tasks. Maybe we should have just done this and talked through this instead of me kind of going through it the other way. So in the package.json, think about your shopping list, all the libraries and tools, and then all of the different bits. In the source folder, this is where all the magic happens. So this is the heart of the application. In main.txs, this is literally the line of your app running. In the app, it's the shell. So as we kind of said before, the kind of key configurations. Here are your full pages, the different screens. The components are the Lego bricks that you're kind of building up. The layout is the kind of key parts of the layout. This project uses vertical slice architecture. This means each feature has its own mini app with everything running and bundled together. I think it's done a better job than me, to be honest with you. Then we've got all our components. So what the components is the visual pieces that you see. The rack hook manages the different states. So for example, using tasks, task manipulation. The schema has the different database rules. The servers are the waiters, so they're the ones that's talking to the external services. In lib is your toolbox of the external services you're working with. you can see here it's unbelievably detailed of telling you what's happening. So let's ask another question. My trainer or tutor kind of said that this file is unbelievably important and that I should never share it with anyone, or I should never put it into source code and GitHub. What does that mean? I don't really understand what you meant by this. Surely I can just share it with my team and then everyone can use the same thing. So obviously here, like I'm trying to be a little bit kind of pedantic and prove a point. So like this is such an important file. So hopefully it'll come back now and be like, no, if you check this in, it's going to blow some stuff up. But as we said, the .env is where you're going to put your typical username and passwords. What hopefully it comes back now and says, and it probably already told us up here actually, or did it not? If it didn't tell us, yeah. So if you look here, it said that .env, your secret values, APIs, this shouldn't be shared publicly. So important. So now it's gave us the most. Wow, this is pretty in depth. So it contains your secrets, like for example, those local keys. And it's giving you all the details of why you might want not to share that, which I think is unbelievably important. So in the background, when we've been working, I think we're finished. So let's just make sure. So it's saying now that the application has finished that there. So if we just kind of go back through, sorry, I'll just bring these ones down. Cool. So the files that it's created is all this stuff here. And the stuff it's modified is this stuff here. Yeah, Supabase already running with the migrations applied. Then create a task. So let's see if it's lying to us, if it's actually done it. Sweet. So let's go into our database and see what's happening here. So it's lied to us. So what it's done, I think, is deleted all our users and stuff like that. Okay. So that's a really good learning point again. There is no users in the table and you have deleted everything. Can you re-add? So basically here it is, and this is one of the things where like you just need to work with AI to understand what it's done there. So essentially like what's happened here is when I've tried to go and press login, it is said here invalid login credentials. There's nothing wrong with my login credentials at the moment. What's happening is there is no users in the database. So if we kind of look here and we look in the database, it's just added this now, testitexample.com. But it didn't have that in before. So let's have a look now. So it's created the user. It's hashing the password locally that it's going to give me. So we could have done this inside the database, but let's do it. So the profile trigger didn't fire. So basically, when you create a user in the authentication table, it should automatically create the profile. It uses something called a trigger, which is essentially like a function, and that hasn't triggered. So it's working on at the back end. So at the moment, it's calling this REST endpoint. So it's calling Supabase, saying, go and set my profile up with all this data. It's running the thing at the moment. So it's a no such container, DB TaskMaster. So it's trying to kind of work it out. So now it's going to Docker and it's saying to Docker what tables I've actually got access to. And then it's looking through the ports. Cool. So now it says it's set up with this user. So let's give them a try. So it was test user. And for anyone on the stream, the only reason that I'm using an insecure password is because everything's running locally. Next week when we work with the remote systems, I will be using a very secure password and password managers. So just for testing, everything's running locally on my computer at the moment, and that's the only reason that I'm using that type of password. So if we add a new task and test task, test in progress, create tasks, and then down here there's subtasks. This is a subtask. This is a new subtask. Sweet. If we tick it, the subclass is done, and we delete it, and we save the changes, and the subtask remains. So it appears that functionality appears to kind of work and meet the spec, which is all pretty cool. So the final bit that we're just kind of going to talk to, a quick recap, talk a little bit about testing and what's been happening in the back end, and then we will wrap up for the session. So the final bit we didn't speak about is the mechanism that we can run this time is very different from what we run last week. So when we were running the user stories, what we ran was full tests. So for every feature that we built, we have a whole bunch of comprehensive tests, and we're kind of using that to kind of prove the quality of our code. So in software, the kind of code quality that you're building is the most important thing. And as I said, if you are completely new to programming and you want to go and build something that you think you can make money from, either like just spend an extra couple of weeks of really going through with the LLM to understand what's happening, or join a community, or before you put something live, maybe just get someone that's kind of got a little bit more experience to kind of go through the code and make sure that nothing really has been implemented badly, because ultimately the worst thing that you'd ever want to do is expose someone's data. So one of the mechanisms that you can use with AI, though, if you before to get that quality assurance process, is you can use testing. So you can kind of think about testing like a little bit like spell checking, where you can have the system check that the actual functionality that you've built is kind of high quality. So we get different types of tests. We can have tests at the smallest level that we can, if we think about that components and hooks that we spoke about before, that just does that at that individual level. We can have an integration test that can look at the whole vertical slice and test the whole feature. Or we can have an end-to-end test where we can actually have the browser, and what I just done there, by clicking through the application, we can have the AI do that for us. So I didn't do that there just because it would have looked really weird with like browser pop-ups having before. But that manual testing that I done at the end with adding the data and making sure everything worked, we could have got the AI to do that as well. So essentially, like this in tests, the kind of whole reason behind them is when you go and change the functionality, the test will still run. So if you break something, the test is going to tell you. So essentially, like what I have done inside the background, inside of the specs that I've done this time, I've said every single feature has to have detailed tests, and those tests need to pass before the application's finished. And why would we do that? So to kind of catch bugs, most importantly. So like if we have got a rigorous set of tests for logic that we've read, that's going to be pretty good. We can make changes to our system in confidence. So let's say we've got a login feature, we change the mechanism for login. If we've got a robust test harness that kind of checks the functionality of the login, we can, when we go in to make changes, we can be really kind of have a warm fuzzy feeling that it's not going to break anything. Tests are really important as well because they also like document what you're thinking and stuff like that. So in tests, typically you would describe them in such a way that makes sense. So sometimes you'd like, given I'm on the login page, when I click, when I give my username and password and click login, I'm taken to the dashboard page. So like when you're kind of putting these tests together, or the AI is putting the test together, they can describe the way the logic is working. And it really will save you time in the long run. So I can absolutely promise you it. In spec-driven development, it's going to take you twice as long to go through a spec cycle when you've got tests. Believe you me, if you don't do that, then what you're going to see for that half a time saving, you're just going to get lots of bugs in your code. And like the bug that we got earlier today with this one, and adding this bucket, it's got nothing to do with the AI. That was to me, that's because I didn't read the spec properly, because if you go back and read it, it said it was going to create another table. So that was just me going through that too fast on the stream, which is a great learning point for everyone. So basically, in the application, after you've got your tests, these are the commands that you can run or the AI can run. It also can generate these coverage reports so that it can say what's tested, what's not tested, that type of stuff. And down here, it speaks a little bit about like patterns and stuff like that. We won't cover that too much. The key thing to just take away here is when you're doing these things and you're trying to do them robustly, do testing as much as you can, because it's particularly for people that have not coded before, it will just give you a lot more reassurance that the code that you're doing and code you're building is actually doing what you think it is. So that was just the different spec kits. Cool. So let's just go through really quickly what we've kind of covered today. So first of all, we explored what we done the last session. So we spoke about growth forms and spec-driven development and things that we went through. Then we spoke about the key features that we're going to be building today, the buckets. So like, as I said, the bucket one that I said wasn't very well described, the checklist feature. And then we spoke about Docker. So Docker is where we're going to be hosting our local database. The database that we're using is Supabase. And as I said, the analogy that we used there was like a pack lunchbox or a container. And the reason that we want to use that is that when we write something, that we can have it the same on different computers. And essentially it kind of solves the headaches of installation and make sure the same thing runs in different places. So if we've got a team member that uses a MacBook and a team member that uses a Linux system, we can have that all in one place. I'll come to that one just at the end, Javal. So Javal also had a really good question. Is Speckit good at covering edge cases in tests? We'll stick a pin in that. We'll come to that one really soon, pal. Then we spoke about GitHub. And as I said, like if you want to go into more detail with this, just work with the LLM. But really what GitHub is a version control system so that we can store and save different versions of our code. And equally important, what it also gives us is a way to work with different features. So if you've got different team members doing different things, we can build our code in the right way. So for example, today in this stream, it's just kind of showed a real use case. So let's say, for example, we were just working on this main branch here where everyone's working on the same code. Then what we went and done was we built that buckets feature, which wasn't to spec, it was broken. So if we had then sent that into GitHub, and with that broken feature, the customer would have got a spec that wasn't right and wasn't performing right. But because it was on this feature branch, it means that it's not broke the normal code, and we can still experiment and get it fixed and get the business logic fixed, which we should have done really in the first place. So what happened when you use Speckit, it built a new branch, first of all for the bucket feature, then it built a new branch for the checklist feature. So it's actually done that in the background for us. And then it speaks about some of the key commands in Git, which is really cool. We've done the absolute basics of databases. And once again, like as a hunt, the best thing that you can do is learn by doing. So when you're working with these things, you're working locally in your computer, you can kind of play about with the database, add data to it, delete tables, understand kind of what you're doing. But the most thing is just to ask questions. So like you can ask the AI, what is a table? What is a column? How do I add new data? And then it's going to come back and help you through that problems. We use the spreadsheet analogy with the main part being the difference how things are linked together. So if you use VLOOKUPs before, it's very similar, but essentially it's something called a primary key foreign key relationship, which links the different tables together. Then we walk through the code base. I murdered it. No, I didn't. The AI murdered it, and I actually literally murdered it. So I think the AI done a little bit of a better conversation than me when we talked through all of the different components. And you can kind of go through these in your own time. And once again, just talking the AI through it. Then we spoke about AI and using AI for quality. So coming on to Javal's question. So I've only been using Speckit myself now for about a month. And when I've kind of been generally running tests for specific edge cases and things that are tricky, one particular feature that I was doing around some complex logic that was running some stuff against the database, and essentially like it was I had to do a certain execution order to kind of make sure that things were committed in a certain order, and it got the tests really wrong for them. So I'm not sure if that was me and the way that I was given the documentation to the testing library, V-test that I was using, or if that was so. In that particular scenario, I really worked through my spec thoroughly. So the spec was right. I believe the documentation I gave the AI right, and the problem, it couldn't solve it. So literally, like, it was me going into the manual code, going into the database and triggers. And Ed, who's also in this call here, one of the things Ed's my partner, and we've been working together some doing this. In Supabase, there's these things called role level security, which is basically these kind of configuration rules that you can put over your database through columns, through tables, through records. And on a few occasions, what we've also saw is that getting that really wrong as well, and it's really hard to debug. So I'm not sure if that answers the question fully, but what I would say is I have saw use cases when we're doing things that are slightly more complex and the AI not managing to solve the problem. That could still be user error. I hope that answers your question, Javal. And then we spoke about the things that we implemented, and that was the key things. So that's the end of the stream today. So next week is going to be probably the most fun. So next week we're going to try and build something that's going to be fairly complex. So I'm going to build a CRM application. I'm going to build it out quite a lot beforehand. And then we're going to go through another couple of features. So the key thing that we're going to look at next week is actually getting some code into an environment that we can kind of play about with it on the internet. Once again, it'll still just be using completely mock data. But the thing that's good about Supabase and some of these other tools, they have got really generous free tiers. So if you are starting to play about with an application and you want to share it with your friends to get some preliminary feedback, we'll look at that deployment architecture and getting it in. So the thing that we're going to be building is a HubSpot competitor. So essentially, if you've not come across HubSpot before, or Salesforce, there's something called customer relationship management software, and essentially that's where salespeople really manage all their deals. So we're going to be building contacts, deals, and companies. We're going to build a pipeline over the top of it, and then we're going to do some extra cool things. Might even connect to a couple of different APIs with the details. And then after that, so this is what we're calling Co-Engineers Season 1. For Season 2, me and Ed are working on some really cool stuff for coming out in February. So that's it for today, everyone. Thank you, Cheval, Ed, Shafiq, the people that have been sending me messages on LinkedIn. I've watched it on their own time. We're really just starting here, so this is my 4th time streaming in the last five years. So I really love some feedback. I think the feedback in particular around when we're kind of running the AI and the best way to go through it. So what I've been thinking about is like, what is the best way to do it? So anything that you can give with feedback about the stream and stuff like that, it'll just help him improve it. So if I don't speak to you before, have a cracking weekend, everyone, and I will kind of chat to you next weekend. Cheers.